This talk is titled Path to Resilient and Observable Microservices. So just quickly about me, my name is Peter Jausovec. I'm a consulting solution architect at Oracle. It's a fancy title. Previously, I worked at Microsoft. I worked on tools such as Visual Studio, SharePoint, and more recently Azure. I also wrote a couple of books. The cloud native one is coming out in a couple of months, I think. The others are already out. You can follow me on Twitter. Sometimes I have interesting things to say. So yeah. So what I'm going to talk about today is not microservices, at least not directly. Since you've probably heard about microservices a lot, especially if you've been in the previous talk. I'm not going to spend too much time on theory. I'm just going to show you some things to keep in mind while you're implementing microservices, and then show you some tools that you can use to make your services more resilient, and some tools that you can use to test your microservices, or rather to test for microservices resiliency. So the first thing you're going to notice when you start breaking down your monolith is that you'll end up with more things to manage and more things to think about. Previously, you probably had a single code base, you had a single deployment, and now all of a sudden you're doing multiple deployments and you have multiple code bases, and all these different things, they need to work together. In addition, you're probably not running just a single instance of each component. You're running multiple instances. And all these things make stuff even more complicated and complex. With so many instances, you need to figure out a lot of things. For example, how are you going to deploy all these instances across all of your multiple machines? One way is you can go and SSH into each machine and do this manually, but that's probably not the right way to do it. You need an orchestration tool, and Kubernetes and Docker can solve these things for you, right? You can use Docker to package your applications and services, and Kubernetes will make sure that your services are evenly distributed across all the VMs. It will also provide health checks and readiness checks for your services, meaning even if your service container crashes or restarts, Kubernetes will make sure to bring it back up, right? However, just simply restarting your containers when service crashes, that's not good enough. You cannot say that your service is working well and all good if it's crashing. So what you really need to achieve is you need to make your services resilient and observable so you know when something goes wrong. So what is resiliency? It's not necessarily about avoiding the failures. It is responding to failures in such a way that there's no downtime and there's no data loss. A simple goal, we could say, for service resiliency is to return the service to a fully functioning state after a failure occurs. There are two aspects when we're talking about service resiliency. First one is high availability, and this one basically says that your service is running in a healthy state, there's no significant downtime, service is responsive and users can interact with it, also services meeting SLAs, etc. Hope you appreciate my choice of emojis. The second aspect is disaster recovery, and this is the only emoji that I could find that would fit this slide. So what is disaster recovery? It is all about how to recover from rare but major incidents, right? And it involves data backupping and archiving and stuff like that. You can also say that disaster recovery starts when the high availability design can't handle the impact of failures anymore. So all of a sudden you have so many failures and the impact is so great that even with the high availability design, you cannot handle it anymore. That's when you're in disaster recovery. And I hope you're never there. So what is the path? How does the path to service resiliency look like? The first step is you need to understand your requirements. How much downtime can you handle, or how much downtime is acceptable to you, right? And this is different based on, it's different from company to company and service to service. So you have to define and understand that. The downtime is also related to cost, of course. So more downtime you have, more broken SLAs and SLOs are in place. You have unhappy customers, and if the customers are not happy, you're either not making money or you're losing money. Next one is to define service availability. So what does it mean for a service to be available? Is it that your website is up and running? Is that enough? Or is it, can you go a step further and say, well, I also want my users to submit orders and make purchases, right? So again, this is something that you need to define. What does it mean for you when you say service is available? Next step is to design for resiliency. So as part of this step, what you need to do is you need to identify the failure points in your system's architecture. So you need to define and identify what can go wrong and how can it go wrong. Next one is strategies for detection and recovery. So the thing here is, how are you going to detect the failures and how are you going to recover from them when they happen? So you would ask yourself questions such as, how will the service detect the failure? How will the service respond to it? And how will I log and monitor for this failure? For example, you could say, if service is unavailable, it will return a 500 HTTP status code. Or if the caller is not authenticated, we will return a 401 status code, et cetera, et cetera. But then you also need to make sure that these errors are properly logged and that you're monitoring for them. Testing is the next step. So with all these things done, you've created your design, you've defined what availability means, you have your strategies in place. If you're not testing for these conditions, you will never know if this actually works or not, just like with everything else. So you need a way to simulate failure conditions so you can ensure that you can detect and recover from these failures or these failure conditions. Finally, if you're not doing monitoring, you're pretty much flying blind. So you need to know what you're doing, right? And without monitoring, there's no way for you to know what you're doing. Next, I'm going to talk about some strategies that can help you with service resiliency, right? The first one is load balancing. So any service that you have should be able to scale it out by adding more instances to it, right? So instead of having a single point of failure, you're going to have multiple instances of your service. You're going to have a load balancer in front of it, and that load balancer is going to use a load balancing algorithm, whichever you pick, round robin, whatever it is, and it's going to it's going to balance the traffic across all of the instances. Next strategy are timeouts and retries. So timeouts are crucial in making your services available. Network introduces a lot of unpredictable behavior, one of them being latency. So how long do you wait for your service to respond? 5 minutes, 5 seconds, 10 seconds? How do you know if something is wrong or if its service is just slow, right? You just wait. Generally, just waiting is really bad because there's either a customer at the other end or there's another service at the other end that's waiting for a response. And this waiting without any timeout in place uses resources and could cause other services to wait, leading to potential cascading failures. So the solution here is always have timeouts in place, right? Even when you have timeouts in place, network could still experience like transient failures, and only if you retried one more time, the call might have succeeded. So the guideline here is make at least a couple of attempts before calling it quits, instead of just making one retry and just throwing your hands up and leaving, right? There might be a transient failure. If you retry once or twice, it might have worked. Of course, make sure that based on what your service returns, you're not just blindly retrying something that's not retryable, right? So you need to define a retryable errors as well, right? Also, the delays between retries, those can be configured, and there's a bunch of different ways to do that. You can use a hard-coded same delay between each retry. Probably don't do that. A better way is to use exponential backup, where with each additional retry, you're waiting longer and longer. So that way you're not just spamming your service unnecessarily, and you're not causing unnecessary strain to it. Next strategy is our circuit breakers and bulkhead pattern. So I mentioned that cascading failures can occur in the system. So a circuit breaker pattern is what you can use to prevent additional strain to the system and then actually prevent cascading failures. So the way circuit breaker works is that it encapsulates the functionality of the services that need to be protected. And in addition, you need to configure a threshold in your circuit breaker that will cause it to trip. For example, you can say, if there are 10 consecutive failures in 5 seconds, or if there are more than 2 connections and X failures in 3 seconds, once those values are exceeded, what's going to happen is the circuit breaker is going to trip, and it will remove that failing service instance from the load balancing pool for a predefined amount of time, a minute or 5 minutes. So that way, you're not unnecessarily calling a service that you know it's going to fail. Similarly, bulkhead pattern. Bulkhead pattern is just a way for you to isolate critical resources. So failures in your website or failures in services that represent your website are not going to impact your billing or your other parts of the system, right? This comes from I think from Marine World, where there's bulkheads, and you can shut them off, so it's not going to flood the whole vessel. Right? Next one is data replication. So data replication is just a general strategy for handling non-transient failures in data store, and many storage technologies have this replication already built in. Graceful degradation. So the idea here is that if one service fails or stops working, the whole system should still continue to work. For example, you can still provide an acceptable user experience even without all of your services up and running. An example that I usually mention here is Amazon. If you go to Amazon.com, there's somewhere on the page, there's a recommendation widget or portion of the page that recommends new products based on your past purchases. So Amazon probably is not going to show you recommendation pane and then there's going to be big bold red letters that says errors, right? They're still going to show you recommendations. They might not be up to date. For example, if the service is failing, they might be using cache values, right? And giving you old recommendations, right? So the strategies here are to use cache values, put items on the queue, in the end show the error message as well. But the idea is don't bring your whole system down if one of your services is not working. Finally, rate limiting. Make sure you are rate limiting the request to your services. So no single user can create an excessive load onto your system and then bring it down. For example, any public API that you sign up for is, in most cases, rate limited. For example, you cannot make more than 1,000 requests within an hour or something. If you do, you're going to get back a HTTP status code that basically says too many requests, wait, right? So especially if you're exposing public services, make sure you have rate limiting in place. So this is all nice. Theory is always nice, right? So how can you actually implement this or use it in the real world? I'll talk about how service mesh can help you with this. But please, this is not the definitive and only way to do this. There are multiple ways to do this. I just decided to pick service mesh, and I'll show you how you can do all this with a service mesh. Next to microservices, you might have heard people talk about service mesh as well. So I'll just briefly explain what a service mesh is. The definition says that the service mesh is a dedicated infrastructure layer for managing service-to-service communication to make it manageable, visible, and controlled. If you distill this, it's basically all about communication between services. So on the slides, on the left side, you can see these three services that are very happy. They're communicating with each other directly. On the right side, we have the same three services, but additionally, we installed service mesh on top of it, right? So what service mesh does, it installs a proxy next to each instance of your service. So your services are not talking directly to each other anymore. Any incoming or outgoing traffic from your service goes through the proxy. So the proxies are talking to each other versus on the left side where the services are talking directly to each other. So the behavior of these proxies is then controlled by the service mesh's control plane, right? For example, if I want to change the way services talk to each other, I can come up with this set of rules, I can apply them to the control plane, and that control plane will in turn convert those rules to the configuration that the proxy understands, right? It's gonna push it to the proxies, and the proxies are gonna reconfigure themselves automatically, and boom, you have new rules on how the services talk to each other. I'll talk specifically about Istio service mesh, and this very nice diagram on the right side represents a sidecar proxy model where each service instance has its own proxy. There are other service meshes out there. I want to mention Linkerd. It's getting very popular. They either use the same model, which is sidecar proxy model, or there's also a model called per host, where instead of having an instance of a proxy for each instance of a service, you have a single proxy instance that's running on a node that runs multiple services, right? So it's uses less resources, but it takes more to manage, right? There's more chatter going through that one proxy. At a high level, this is how a service mesh works. A great benefit of a service mesh is that you can push certain functionality out of your services. For example, timeouts and retries that you originally had in your service, you can push it out to the proxy, right? And then proxies can deal with it. So instead of, as I said, instead of implementing retries or timeouts and having those in each service separately, you define those settings on a service mesh level for either each service or group of services, and then you apply it to the proxies. The proxies then take care of any retries or timeouts because they are the ones that are talking to each other. It's not services anymore. So if we go back to the list of strategies, this is what the service mesh can help you with. It can do the load balancing for you, timeouts and retries, circuit breakers, and it can also do rate limiting. There are also other things that service mesh can do and can be used for, such as traffic management and security, but those are out of scope for this talk. So let's talk about how you test for service resiliency really quickly. This is not the same testing as like running unit tests or testing for functionality. This is testing how your services perform under failure conditions. At a very high level, there are 3 steps when you're doing your testing. You need to conduct the test, you need to measure the behavior, and finally, you need to analyze and fix the issues, of course. And once you're done with that, then you go back to the step one, and then you repeat this over and over again, because there's always bugs and something's going to go wrong. There's always that. So Service Mesh, the way it can help, it has the ability of injecting failures and injecting delays, meaning with the configuration, you can configure the proxies to say, I want 50% of the requests coming to this service to return a status code, HTTP status code 404, for example, right? And this is all done on the proxy level. You don't have to change any of the code. Similarly, you can say, well, I want calls to service B to take an extra 5 seconds, right? So every call that's going to be made to service B is going to take an extra 5 seconds. So with the help of this, you can simulate those failures and see how your services and how your whole system behaves, as well as see if you can actually detect these failures through your monitoring and through your logs. Let's talk about observability. So observability is the act of measuring, collecting, and analyzing metrics, traces, logs, events, and any other signals that are coming from your services. It is crucial for resiliency, because you need to know something failed, and you have to have enough information to figure out what caused the failure. So observability, in a sense, it allows you to investigate stuff. There are also multiple parts to this pipeline. So first of all, your services need to emit the data. They need to emit metrics and logs. Next, you need to collect and store those metrics somewhere centrally. Once you have it stored, you can analyze it. And finally, after you've analyzed the data, you can search for errors. You can visualize them in Grafana, for example. You can alert on certain conditions if you wish, and then connect it to PagerDuty, et cetera, et cetera. So in order to be able to successfully investigate stuff, you need to make sure that you're following some good practices with your logs and metrics. So these are like just a couple of tips, I would say. There's plenty more. There's plenty more things. I just picked out a couple of them. First one is to use correlation IDs. So a correlation ID allows you to trace your calls throughout your system using the same ID. So the idea here is I go to your website, I click login, or the first action that I do on your website, you create a unique ID, and that ID gets passed down to each service that gets called, right? In case something goes wrong, you get this nice trace with this unique ID that allows you to search throughout your logs and basically see what happened. A good example here is some of the CLIs, for example. Like you call the CLI, you get a call, they usually tell you, oh, something went wrong, and here's the correlation ID. So what you can do with that correlation ID, assuming you're persistent and you really want the CLI to work, you can go to support and you can say, hey, I got this correlation ID. Here we go. You go and find through your systems and logs and tell me what's wrong, right? Help me out. Next one is to use structured logging. So the idea here is it has to be structured so you can parse it, right? Make it, like I would always say, make your logs more machine readable and parsable, because that can help you make them more human readable. If you start with human readable first, it might be very hard to parse them later if needed. Next one is a no-brainer, but it always happens. Make sure you're not logging any private information. If you do, make sure you're obfuscated, but I would err on the side of caution and just don't log any private information at all. For metrics, make sure that the names are unique so you don't run into collisions later, or run into, like you might have issues later if your metrics are either named the same way or very similarly. Categorize the log entries, so there's multiple log levels that you can use. There are multiple categories that you can attach to your logs. Start with info or a debug. You can do warning, error, but don't start with too many of them. Start with 1 or 2 first and then expand if needed. Finally, use a common format when logging. For example, or especially time zones and time formats. So that nice monolith that we had before on slide 2 or 3, we broke it up into multiple microservices, and after a couple of months or years, you're going to end up with more and more microservices. So now imagine if all those instances are using different time zones and different time formats, and then something goes wrong, and then you have to look for errors or trace through the logs. You're going to have a really, really bad time, right? So really make sure that you're very consistent with the way you do logging, and use a common format. Of course, also include like context information with each log message. So once the metrics and all those signals are collected, you need a way to represent and visualize this data. So here are just some of the tools that I'm going to talk about, and the first 3 I'm going to actually show you in the demo. So Grafana is a tool that has a nice sets of graphs that can be backed by Prometheus data or other data sources. Basically, if you've never seen Grafana, it can create like a really nice looking charts and gauges and so on. But if you haven't seen it, you'll see it very soon. Jaeger is another tool that's used for distributed tracing. So with Jaeger, you can do, remember that example that I mentioned for the correlation ID? Jaeger is one of the things that you could use to trace the calls based on the correlation ID throughout your system. Next one is Kiali. Kiali is the service mesh dashboard, and I'll show you this as well. And it's installed together with Istio, so I'll show that as well, how it looks like. EFK stack, so this is Elasticsearch, FluentD, and Kibana. So FluentD is similar to Prometheus, but instead of scraping services for metrics, it scrapes the logs from your containers. Then it takes those logs and sends them to Elasticsearch, where they're indexed. And then finally, Kibana is used to search through their logs, and also has some dashboarding functionality. Finally, PagerDuty. Personally, this is the worst one for me. I don't know how many of you used PagerDuty or heard of PagerDuty. If you've ever been on call, you probably know what PagerDuty is. For those who haven't been on call, so PagerDuty is this evil thing where you log in, you enter your phone number, you enter your email address, your blood type, et cetera, et cetera. And then if something goes wrong with the system, if there's an alert, the PagerDuty is going to call you. Usually it's going to be 2 or 3 in the morning, right? So the way PagerDuty works is it hooks into Prometheus data, and based on those data, based on that data and those queries, it can trigger alarms or alerts. And then, for example, if the availability of your service drops below 100, it's going to call you. All right, so it's demo time. So in this demo, I'll show you some resiliency features of the service mesh. I'll show you timeouts and retries. I'll also use HTTP delays and aborts and inject them just to give you an idea how you could test your service. And then for the observability part, I'll show you Jaeger, Grafana, and I'll show you Kiali as well. Just quickly about the demo, it's a very, very, very simple demo. Three services. I have a weather service. This is the service that I'll be making calls to. And this weather service, in turn, will call a city service to get back the city and the state name, I guess. And it will also call the temperature service to get back the temperature in that zip code. And then the weather service is going to collect the data, and it's going to return me that JSON blob that you see there in green. All right, so I'll exit this. Okay, so I'll move this out of the way. Let me just open my cheat sheet here. All right, so let me talk about quickly what I have installed here. So I'm running Docker for Mac. I have Kubernetes running locally on my machine. This demo can be done with Docker for Mac. You can do it with Minikube. You can do it with any of the cloud providers managed Kubernetes offerings, right? So the only difference is I'm running it on my machine and it's eating a lot of memory, right? So let me run kubectl is the CLI for Kubernetes. I have it aliased to K, so if you see me type K, it's kubectl. So let me just show you the nodes. So I have Docker desktop. I have one node that's ready. Also, let me show you the pods. I have Istio installed. So Istio installs a bunch of stuff, right? Like gateways, ingress, egress gateways, pilot, which is one part of the service mesh, stuff for telemetry and tracing. It installs Kiali, it installs Grafana, and it also installs Prometheus. So this is all out of the box install. I haven't done any extra customizations here. All right, so what I'm gonna do is I'll deploy my weather, temperature, and city service. There you go. So I'm gonna wait just a little bit for this to get deployed, and then we can see the progress. So you'll see this one is saying 0 out of 2, meaning there's 2 containers here. One is the actual service, and the second one is the proxy that I mentioned. So this is the proxy that gets injected when you install the service mesh. All right, so I have 2 out of 2, everything is running, all is good. Next thing that I'm gonna do is I'll deploy the first Istio resource. This resource is called Gateway. And what I'm doing with this is I'm saying I wanna poke a hole through my cluster so I can allow traffic to go inside my cluster, right? That's all that it's saying. And it's gonna use this Istio Ingress Gateway. It's gonna be on port 80. I'm gonna support HTTP. And I don't care which host it is, just let everything in. All right, so let's deploy this. Gateway was created, so if I do get gateway, you'll see this is very useful, right? There's gateway here. Next, what I'll do is I'll deploy a resource called virtual service, and I'll deploy this for all 3 of my services. And this might look like a lot of text. Well, it is a lot of text, but I'm just gonna pick the weather service here. So I'm deploying a virtual service called weather service. I want this service to be accessible for all hosts. It doesn't matter. I'm also attaching a gateway to this virtual service. And this basically means I want this weather service to be exposed through the gateway named gateway. And this is the thing that I deployed a couple of seconds ago. Down here, this is where you can define your routing rules. I don't have a routing rule here per se. I just have a single destination, which is my Kubernetes service. So this is the DNS name of the weather service that I deployed. And the service is accessible on port 80, right? And later you'll see how you can do some more rules there. All right, so the virtual services were created. I'll show you that, there you go. And it's saying city service host, temperature service host, and then weather service exposed through the gateway, any hosts, right? All right, looking at my cheat sheet. So with this deployed, I'm moving to the lower portion down here now. I'm just gonna curl to localhost because, I'll show you, this is running the gateway or the Ingress gateway is running, on my local host, right? This is the external IP of it. So if you had like a real cloud managed Kubernetes, you would have an actual IP address that's accessible through the, from the public internet, right? So I'm able to make calls. So let me do this. I'll just continuously make calls so we can generate some data, and we can also see see how the failure injection and delay injection and all that can impact the results. It's all in nice. So let me do this. I just have some aliases there to allow me to start things like Kiali. So I'll show you Kiali first. So as I mentioned, Kiali is a dashboard for microservices. Service mesh observability, that's what they call it, right? And let me also start Grafana, Grafana and Jaeger. So if you're wondering, these are just the aliases. What it's doing is just doing a port forward to Kiali, Jaeger, and Grafana pods that are running inside my cluster, right? So let's just refresh this one to make sure it comes up. Okay, Grafana, all right. So let's look at Kiali really quickly. So Kiali is gonna show you all the services that are running in your service mesh, right? There's a weather service, there's a temperature service, city service. It also uses the labels that are set on your deployments. So if I had multiple versions, I would see multiple versions. This is always the thing that I turn on, and it looks really nice. So it shows you how the traffic is moving, right, through the services. There's different views of the service, right? It has a lot of nice features. This was this. Let me also go to Grafana a little bit. If you've seen Grafana, this is familiar. Note that all these dashboards here, this was all installed by default. With Istio, I didn't go in and modify anything here or create any additional things here. Let me open this up. And it automatically, based on the traffic, right, the metrics that the proxies are sending, it knows that there are 3 services, it knows their names, and it can also gather a lot of data, right? It gives you a lot of nice graphs, shows you the incoming requests, shows you the outgoing requests, shows you the city service, right? And then it shows you the temperature service, all 200s, everything is good, right? Finally, Jaeger, this is for tracing. Let's do just a quick demo here. So you can see the call came through from the Ingress gateway, went to the weather service, and then the weather service made a call to the city service, and it made a call to the temperature service. It also gives you durations, gives you some more information about, for example, what was the request ID, what was the URL, the method, user agent, et cetera, et cetera. Note that this, this information is not, you don't get this by default. What you need to do, and what I did in my source code, is in the weather service. So there's a bunch of headers that get set, automatically generated. And what you need to do is you need to take those headers and then just make sure that they get forwarded with any downstream requests you're making. So every time I make a call to the city service or temperature service, I take those headers that I got, the incoming request headers, and just make sure that they're attached for the next service. And those headers, the idea behind those headers is to help Jaeger stitch together all these traces, right? Note that this is also only at the edge of the service, right? So it's only call coming in, call like from service A to service B. What you could also do is you could create additional spans and metrics and traces within your service. So for example, within my city service, I could have created or emitted more spans and more traces. So this could get more detailed if needed, right? So this is only at the service edge. All right, so let's go with the first service mesh feature and show how one can, I'm gonna inject a failure. So this is the same virtual service that I deployed before. It's gonna be for the city service. I'm gonna define a route, the destination, still the same. But then additionally here, I'm saying I want to inject an abort for 60% of the incoming requests. So 60% of the incoming requests to the city service will return a 404, HTTP 404. For example, well, let me just apply this, right? For example, if you wanted to see how your service behaves. So down here, I know it's going like it's going by really fast. I'll try to catch it. There you go. So down here, you can already see that service return a non-200 code 404 fault filter abort. So this is basically telling you that there was a fault filter applied, right, on the proxy level. Similarly, over here, if I refresh, we should start seeing, there we go. So if you see it down here, let me try and zoom in a little bit. There you go. So you can see city service, that's the DNS name. There are 404s here, right? So 404 started going up. There's still a couple of 200s, right? 40% to be exact, because we said 60% of the calls should be 404, right? Similarly, let's see how this looks like in Jaeger. In Jaeger, we could filter the traces based on the status code, and we can say, whoops, if I can type status code equals 404 to find traces. Oh, and I have to do this. And this was city service. Find traces. Oh, come on. Oh, let's see here. Oh, yay, there you go. Okay, a few seconds ago. So this one was a call to the city service, right? And the status code was 404, and the response flags are set to FI. This means failure injection, right? Quickly, just to Kiali, this is another nice thing that you can see. You can see that there's red here where it was green before, and it means there are 400s some percentage of the time, right? So this is also a nice way to visualize and see what's happening with your services and stuff in the service mesh. All right, so let's reset it back. The way I reset it back is I'm just gonna, let me just do this so you don't have to look at those things. The way to reset this back is just to deploy the same virtual service without any of the failure injection code set. Let me do it here. All right, so this is deployed, and now you'll see the errors. The errors will stop here eventually. Okay, so the errors have stopped, and I think here it's going to take a couple of minutes for this to become green again, because it's looking at the traces for past 1 minute, and then I don't know the math involved here, right? But it takes a little while. Over here, let me zoom back. If I refresh, this one we should see that it goes all the way down to 0, and this one has Grafana has the same thing where it takes a little bit for things to come back, right? So you see this one is already like spiking up, and it's going to be all green.